Now we're going to introduce two new words to you. Well, maybe one of them is not a new word, but I would guess tautology is a new word for you. And that is something that is always true. You can run a truth table, and if the resulting final statement is true all the way down, that means it is a valid argument, and we also call it a tautology. A self-contradiction is something that is going to always be false. And then something we would classify as neither is the final truth table has some mixture of truths and falses. So here's a great example of a tautology, and you might see right clearly why this is true all the time. We've got P or Q, and not P, then Q. All right, that looks really complicated, but let's read it in this sentence where P is I'm eating at Whataburger, Q is I am eating at Chick-fil-A. So the sentence reads, if you convert those symbols up here, the P's and the Q's, so P or Q, I am eating at Whataburger, or I am eating at Chick-fil-A. And, so there's an and right there, and I am not eating at Whataburger. All right, so if you're eating at one of those two places and you're not at Whataburger, then you must be at Chick-fil-A. Therefore, I am eating at Chick-fil-A. And that's all a true statement. And let's just actually do this little truth table here so you can see that what the resulting thing is. So recall for P or Q, this is true everywhere except for when they're both false. All right, so it's true, 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 and then the final one is false. That's the only time an or a disjunction is false. Now we're going to do not P. So P is true, true, false, false. So not P is false, false, true, true. All right. And then we're going to do an and statement, a conjunction of those two things, P or Q, and not P. So recall for a conjunction, they have to both be true. So true, false is false. True, false is false. True, true is the only one that's true, and false, true is false. And then finally, our last statement is all of that stuff, then Q. All right, so recall for P then Q, the only time we are looking for anything that's other than true is when P is true and Q is false, when the first thing is true. So if we look right here, I have false, false, false. All of those are false, which means this statement is true. All right, again, when the leading thing is false, we know for a conditional statement that the resulting thing is true. And so here we have true, then, and then Q is true. So true, true is also true. And so for this little example right here, we end up with all truths. And when you have your final result is all truths, that's when we call that a tautology. All right. Again, I'll kind of work through some of that logic, the logic steps there pretty quickly. Let me go grab that table and bring it over. And so again, here's that little table that has the basic truth values for all these things I just did, conjunctions, disjunctions, and conditionals, to work through that. A self-contradiction example is really easy. That's P and not P. All right, P stating I am from North Carolina, and I am not from North Carolina. Right? You can't be from North Carolina and not from North Carolina. So no matter what truth values you assign to P, this statement is always false. If P is true, then not P is false, and if P is false, then not P is true. And remember, for an and statement, it's true only when both P and Q are true, and this will never ever be the case where both of these are true. One is always the opposite truth value. So let's work an example down here and see if this statement down here is a tautology. Now this time they have not given us any of the truth table, so we're going to have to start from scratch with our P and Q. And hopefully you've caught on to the pattern. When you have a truth table, we typically do two truths, two falses for P. And then if you alternate P, true and false for Q, it ends up creating every possible combination of truth values for P and Q. All right, so the first thing we want to do is a biconditional, P and Q. Let's look back up here. The biconditional is true only when P and Q have the same truth value. So P biconditional, or P if and only if Q. When it's true, true, it's true, and when it's false, false, it's true. Otherwise, the two in the middle are falses. Then we have or Q. So we have that stuff, and then we have P if and only if Q, or Q. Alright, so remember disjunction is false only when both P and Q are false. So when both of these things are false, then this is false. So right here we have false and false. So Q and P biconditional Q. That right there is false. And so all the rest of them are true because it's a mixture of trues and falses. Alright. And then we say biconditional that, all of that stuff with P. So just to be clear here, I'm going to compare this, and I'm going to go all the way back over here to P at the beginning, and we're looking for the same truth value. Alright, so we have true, true, and then we have true, false. Alright, so we have a mixture right there of truth values, and as soon as we see that that's false, and we have one true and one false, we can stop right there and say, this is neither a tautology nor a self-contradiction. As soon as you have one thing false, it's not going to be a tautology. And as soon as you have one thing true, it's not a self-contradiction. So let's just finish the rest of this table there while we're here. So we have false true is false, and we have false true is false. So you can see we ended up with some combination of trues and falses. So that's how you decide if something is a tautology, a self-contradiction, or neither. In this case it was neither because this was a mixture of trues and falses.